Hello everyone, welcome back to the channel. My name is Sam. In this video we discuss Amazon Route 53 and how it routes traffic into our EC2 instances by configuring the hosted zones with some records. We also delve into routing policies where we talk about simple routing policy, latency based, geolocation and so many others. Please subscribe to the channel, like and share for the YouTube algorithm to promote such videos to people who need them. See you in the video. Today we're going to discuss Amazon Route 53. What is Amazon Route 53? Now Route 53 is a DNS as a service. Okay, it is AWS's DNS as a service. When you talk of DNS, what does it mean? DNS means domain name system. Now what DNS does, it translates understood names such as google.com, example.com, amazon.com to IP addresses. Okay, what it does is it translates names, okay, it translates names to IP addresses. In actual fact, if let's say you want to go to facebook.com and there is no name like facebook.com, but what you have is, let's say, an IP address, say 18.9.71.5. It will be very difficult always remembering the IP address. Okay, so what is done is that you need to register these names such that it will become easier for you to type in your browser. But get to know that the servers do not use this name, they use IP addresses. So if you type in facebook.com, it is this DNS that translates this name or this known name to an IP address. Okay, we will discuss into details how this thing works. Okay, now what are some of the functions of Route 53? There are so many functions of Route 53, but the prominent ones are three of them. One, to register a domain, register domain name. Let's say you have a website, you are done with designing the website, but you would want people to remember the name. Okay, like let's say myhomeaddress.com. okay, Route 53 can be able, you can use Route 53 to register this particular domain. Okay, the next thing is that Route 53 routes internet traffic. It routes internet traffic to your resources, internet traffic to your resources of your domain. After you have registered the domain, it is Route 53 which is going to route traffic to your resources of the domain. Okay, the next thing is that Route 53 checks the health of your resources. Let's say, for instance, if you have EC2 instances, 2 or 3 or more instances, Route 53 does a check, a health check, whether the instance is up and running, whether something is wrong with it. It is Route 53 which does that, and then it sends traffic to that particular instance if it's healthy. Okay, so these are some of the basic functions of Route 53. Now the next thing we will talk about is how does Route 53 route traffic to our resources, okay, in the domain. Now I have here AWS documentation, a diagram to illustrate how Route 53 routes traffic to the domain. Now let's look at this one. The end user is the number one. Okay, so when the end user enters, for instance, www.example.com, when he hits enter, it moves to a DNS resolver. This resolver could be an ISP, internet service provider, or your corporate network. So your internet service provider serves basically as the DNS resolver. Then it forwards the request to a DNS root name server. Okay, so this is some kind of a database where it keeps all root DNS names. Now, when it searches inside, the DNS root server will tell the request that, okay, you need to check in the .com TLD. TLD means that top level domain. So top level domains, we have the .com, we have the .org, .edu, and some of them sometimes is countries .gh, .ng, .uk, .ca. So these are all top level domain. Okay, so the DNS will tell it, okay, go and look inside the .com top level domain, because the request that is coming here is www.example.com. okay, so it will tell it to look inside. So it goes into the DNS resolver again, and then that comes back to the .com name server. Okay, now when it searches inside, it tells it that, okay, we have been able to find the .com, but then it is Route 53 which is hosting the DNS records. Okay, it tells it to go to Route 53 which is hosting the DNS records. So it comes back into the DNS resolver and then redirects into the Route 53. In this Route 53, you have what we call the hosted zones. There are records in this hosted zone. So it finds it in the Route 53 and then tells it the IP address of www.example.com. So the IP address here is 192.0.2.44. It goes into the DNS resolver and then comes back into the browser. So when the browser or the computer has known the IP address, it now comes to search for this server which has this IP address. But then when it is coming or looking for the server, it comes as an HTTP request. Okay, so you can see here http://www.example.com. So it finds the web server which has the IP address 192.0.2.44. So when it finds it, it now renders whatever page the user is looking for. Most probably it will be the home page. Okay, so it gives it that particular information and it renders onto the browser. Then you see. Now I might say that this is quite a complex process, but it takes just milliseconds. It's not that it takes too much time. It takes just a millisecond for you to have a page loaded. Okay, so this is how Route 53 routes traffic to your domain. Okay, so the first one is that the end user has to issue that, type in www.example.com. It goes through a series of processes. It finds the Route 53 and then gets to know the IP address. Okay, and then looks for the server which has this IP address. When it's able to find it, it renders the page so that the end user can be able to see on the browser. So this is how Route 53 routes traffic to our domain. Okay, if you don't understand anything, put that in the comment section and I'll be glad to answer that. Now let's go back to the whiteboard. The next thing we'll talk about is that we need to know a few Route 53 record types. The first one is a record. Okay, this usually maps to an IP address, of course IPv4. Okay, it maps an IP address to a single resource, usually a web server, website, and all that. Okay, so it changes the IP address. It maps the IP address to a single resource, usually a web server. That is for the A records. Now we have the quadruple A. Now this one maps IP version 6. Okay, IP version 6 address records. Okay, now if you don't know all these things, IP version 4, IP version 6, please check my video on public IP versus private IP versus elastic IP. I'll put that in the description box. The next one is the CNAME. The CNAME is basically the canonical name. Okay, next one we have the alias. Now the alias is specific to AWS resources, okay, such as elastic load balancer, CloudFront, S3 endpoint, etc. So when you have any of these and you want to let the DNS resolve it for you, you need to use an alias. Okay, and these are all specific to AWS resources. Now we have the MX. MX stands for the mail exchange record. If you want to configure your mail using Route 53, you need to use the MX, so mail exchange. And the last one, mail, there are so many of them, okay, but these are just a few. NS, these are name server records. Okay, so the next thing we are going to talk about is the routing policy. For the routing policy, we have simple routing policy. Now, simple routing policy is the most basic routing policy which defines an A record to resolve to a single resource. So like I mentioned earlier, it maps IP address, which in essence is the A record. Just as we discussed here, it maps IP address to a single resource. Okay, so simple routing policy does that. So A record to a single resource. This usually website. Okay, so if you have a website or web server, you link the IP address to the, we link up the IP address of the EC2 instance in Route 53, just a single instance, and then it propagates. The next one we'll be talking about is the failover routing policy. Now, as the name suggests, failover routing policy means that, or it is used to create an active passive setup such that one of the sites is active and then the other one remains disaster recovery site, so that if the primary site is down, it automatically switches to the DR site. Okay, so let's say you can have two DNS routing policy whereby one of them will be serving all the traffic. Okay, that is the active one. So should in case there is an issue or there is a problem with it, then the standby site will quickly take over and then begins to serve traffic. Okay, so in this one, it is the health check that does, it monitors the primary site to make sure that it is active. Other than that, if it's down, it moves traffic to the recovery disaster recovery, which is on standby, so that it can still continue working. Now let's talk about geolocation routing policy. Now what geolocation does is it is used to route traffic based on the geographical location from where a DNS query is originated. Okay, so there are most companies, they can have instances located in, let's say, US region, one in Europe, one in Asia. So if there is someone in, let's say, UK, and then tries to hit a particular website, okay, let's say example.com, so it will redirect it to Europe servers. Okay, if let's say someone is in New York and then he hits, let's say, example.com, instead of going to Europe, it hits the US service. Okay, so based on where the DNS query is originated from, that is where it will send the traffic. So let's say someone is in China or India or okay, and then they have instances or servers in China. So when you hit www.example.com, instead of directing to the US side, it directs you to the China or the Chinese site. Okay, so that is geolocation policy routing. The next one is geo proximity routing policy. Okay, so this one, what it does, it routes traffic to your resources based on geographical location of users and your resources. Okay, so let's say I am in Africa. Okay, I'm in Ghana here, and then based on where I am and where your resources are, it will always look for the closest resource, okay, and direct traffic to. So if you hit, let's say, www.example.com, when it hits the DNS, the DNS Route 53 will check where your closest resources are, then it will direct the traffic to that resource. Okay, all right. Now the next one is latency based policy routing policy. Sorry. Now, as the name suggests, if let's say you have two instances, okay, two EC2 instances where they all serve the same purpose, the same application, okay, what Route 53 does is, if it's based on latency routing, what it will do is that it will check which of the, let's say this is an EC2 and this is another EC2. So it will check which of the connection or the traffic has the least amount of latency. So let's say this one is giving us 300 microseconds, and then this one is giving us 40 microseconds, okay, or milliseconds. It will direct the traffic to the one with the least, okay, such that requests can be faster. The request can be faster, so that all requests coming through, it will check, okay, this one has the least latency, and then it will push all the traffic onto this, whilst minimizing this one. Maybe there could be a problem with it, that is why the latency is too high. So it will direct all traffic to the one with the 40 microsecond. Okay, so that is latency based routing policy. The next one we'll talk about is the multi-value routing policy. So this is similar to the simple routing policy, but then the routing policy retains only a single, okay, it's connected to only a single resource, or when there's a query, it gives only a single resource IP. But with the multi-value, it gives you multiple answers, okay, when there is a DNS query. For instance, if you want to get the IP address of all the instances in a particular VPC, you can use, when you query that, it's going to give you multiple IP addresses, okay, multiple IP addresses, unlike this simple routing, which will give you just one IP address when you query that. Okay, that is the last one, is the weighted routing policy. Okay, now what the weighted routing policy means is that we share or we split traffic based on a defined weight. Okay, let's say we have two EC2 instances, and then this is route. Now we can decide that, okay, when traffic hits Route 53, send about 80% of the traffic to EC2 instance 1. Okay, this is 2. And then send 20% to EC2 instance 2. Okay, so usually this is done when you want to test, let's say, a new application, or you want to test something new. You don't direct all traffic to that particular instance or to that particular application, okay, but you do it in a weighted form, such that you allocate a certain percentage that should come to this instance such that you can be able to monitor or roll out that application gradually. When you see the performance, you can now increase the weight until such a time that you think that okay, the application or the EC2 instance is well equipped enough to handle the load. Okay, so that is the weighted routing policy.